This module provides information on the controls and indicators of the Autopilot Flight Director System, or AFDS. The Mode Control Panel, or MCP, has various switches, readouts, and knobs used to activate or control many functions of the Autoflight system. It provides control of the autopilot, flight director, altitude alert, and autothrottles. The MCP is used to arm and engage various lateral and vertical AFDS modes and establish altitudes, speeds, and climb-descent profiles. There is a flight director switch on each side of the MCP. The flight director switches are turned on during pre-flight and the flight mode annunciator, or FMA display, verified. On the ground, when a flight director switch is turned on, the following occurs. Flight director is annunciated on the onside PFD and HUD. Steering indications are displayed on the onside PFD, that is, the roll bar is centered, and the pitch bar appears at 8 degrees pitch up. The position of the pitch bar at the 8-degree position is used to confirm normal pitch function during pre-flight and is not used for takeoff guidance. TOGA is enunciated in the FMA roll and pitch windows on both PFDs and both HUDs. MCP mode switches are used to select the AFDS modes. A light in the switch illuminates to indicate that the switch is selected. Now, selecting a switch does not necessarily mean the mode is engaged. Actual mode engagement is only indicated in the roll and pitch windows of the FMA. Active modes are displayed in green in their respective window. The autothrottle modes only display if the autothrottle is engaged. The roll and pitch modes only display if the flight director is on or the autopilot is engaged. Engaged modes are shown at the top of the FMA boxes in large green letters. When a mode is first engaged, a box displays around the mode annunciation for 10 seconds. This box assists the pilot in quick verification that a new mode has in fact engaged. After 10 seconds, the box disappears, but the engaged mode annunciation remains in view. Armed modes are shown in smaller white letters at the bottom of the flight mode annunciator roll and pitch windows. On this frame, we show various modes that can be armed. Note, the TOGA mode does not have an armed indication in the FMA. An armed mode becomes an engaged mode when the parameters for engagement are satisfied. When an armed mode engages, the small font white annunciation blanks and the mode annunciation appears in large green font. Of course, the box appears for 10 seconds upon engagement to highlight the new annunciation. Several modes don't arm, but instead positively engage with a single push on a mode button. These modes include flight level change, heading hold, track hold, heading select, track select, vertical speed, flight path angle, and altitude hold. Some modes will arm but not necessarily engage when they're selected. For example, selection of the localizer final approach course mode won't actually engage the localizer or final approach course until the capture parameters are met. The modes shown on this frame can be armed with a single push of their mode selector and will engage later when the parameters for engagement are satisfied. However, if one of these armable modes is selected when the engagement parameters are already satisfied, the mode will engage immediately. For example, selection of the VNAV mode when the aircraft is above 400 feet will result in immediate engagement. If armed, the LNAV, VNAV, final approach course localizer, and approach mode above 1,500 feet radio altitude can be disarmed by pushing the respective mode switch a second time. Most roll and pitch modes, except the approach modes at certain times, can be disengaged by selecting another mode. However, All roll and pitch modes can be disengaged by disconnecting the autopilot and turning off both flight directors. Subsequently turning on at least one flight director or re-engagement of the autopilot will then allow a new mode to be selected. The approach mode can be disengaged by selecting another mode until the aircraft reaches 1,500 feet radio altitude with localizer and glide slope captured. Additionally, when above 1,500 feet radio altitude, if the approach mode is engaged, it can be disengaged by reselecting the approach switch. In this case, the roll and pitch will revert to default modes. The default for roll is heading hold or track hold. The default for pitch is vertical speed or flight path angle. When approach is engaged and the parameters shown on this frame are satisfied, the localizer and glide slope modes can only be disengaged by disconnecting the autopilot and turning off both flight directors or engaging the go-around mode by pressing a toga switch. With the exception of the approach mode we've just discussed, when a mode is engaged, you cannot deselect that mode through the mode switch. You must either replace that mode with another mode or turn off the autopilot and both flight directors. Desired target values can be selected on the MCP for airspeed or Mach, heading or track, vertical speed or flight path angle, and altitude. All of these parameters, except vertical speed or flight path angle, can be pre-selected on the MCP prior to flight director or autopilot engagement. Therefore, during pre-flight, you'll normally set your V2 speed, first expected heading after takeoff, and the first assigned altitude. Some target values can be uplinked to the MCP. Airspeed or Mach, heading or track, and altitude values can be uplinked. Pushing the Accept switch accepts the ATC uplink and displays the uplinked value in the lower half of the window. Uplink values are preceded by UL. Pushing the transfer switch moves the lower value into the upper window, leaving the lower window blank. Now, if for some reason the flight director switches and the associated FMA indications were overlooked during pre-flight, the flight director steering indications will display as pop-up guidance when a toga switch is pushed above 80 knots on takeoff. The autopilot switch is inhibited on the ground with flaps extended. After takeoff, the autopilot is engaged by pushing either autopilot engage switch on the MCP. With either flight director switch on, the autopilot engages in the flight director mode. With both flight director switches off, the autopilot engages in the default roll and pitch modes. The AFDS Status Annunciator, or ASA, is displayed just above the attitude display on the PFD and HUD. The indications in this area include Flight Director, Autopilot, Land 3, Land 2, and No Auto Land. Normal autopilot disengagement is through either control wheel autopilot disconnect switch. At any time, the autopilots can also be disengaged by moving the MCP autopilot disengage bar down or exerting override force on the control column or wheel. During Land 2 or Land 3 operations, when the autopilot is directly controlling the rudder, exerting force on the rudder pedals will also cause the autopilot to disconnect. When the autopilot is disconnected, an oral alert sounds and the autopilot disconnect message appears on ICAS. Pressing either control wheel autopilot disconnect switch will cancel the autopilot disconnect alert. Practice engagement and disengagement of the autopilot on this frame and learn to cancel the alert and message. When the AFDS detects the degradation of an autopilot or flight director mode, The condition is enunciated on the FMA by a line through the affected mode enunciation. A flight director mode degradation in either pitch or roll causes the removal of the respective steering bar on the PFD and the guidance cue on the HUD. When the degradation is no longer present, the flight director commands return to view. Now notice on this frame we demonstrate a failure of the localizer mode. If an autopilot mode degrades, the autopilot remains engaged in an attitude stabilizing mode based on the inertial data, and the ICAS caution message autopilot displays. The respective flight director bar is removed from the PFD, and the guidance cue is removed from the HUD. When the degradation is no longer present, the enunciation's clear and the autopilot resumes using the mode. In addition to mode failures, the operation of the stall and overspeed protection functions will cause the flight director pitch bar to disappear. Now, failures affecting all autopilot modes result in an autopilot disconnect. The red autopilot disconnect warning message appears, and an oral alert sounds until either control wheel autopilot disconnect switch is pressed, or if possible, the autopilot is re-engaged. Depending on the system failure, it may be possible to re-engage an autopilot by pressing the autopilot engage switch. With the autopilot engaged for an approach, the following autoland status enunciations are available. With a Land 3 indication, the autopilot system level of redundancy is such that a single fault cannot prevent the autopilot system from making an automatic landing. With a Land 2 indication, the level of redundancy is such that a single fault cannot cause a significant deviation from the flight path. With a no autoland indication, there's no system redundancy and autoland will not operate. An ICAS message is displayed for any fault which limits the capability of the automatic landing system. However, oral alerts for the ICAS caution messages not affecting safety of flight are inhibited below 200 feet AGL until after touchdown. This module provides information on the Boeing 787 Autothrottle system. The autothrottle system provides automatic thrust control from takeoff through landing. Autothrottle operation is controlled from the MCP and the CDUs. There is an autothrottle arm switch for each thrust lever. During normal operations, both switches remain armed at all times. With the autothrottle arm switches in the arm position, the autothrottles may be engaged by pressing a toga switch for takeoff, selecting the autothrottle switch above 400 feet, selecting flight level change or VNAV in flight. If only one autothrottle arm switch is in the arm position, engagement of the autothrottles will only engage the armed side. In this case, the autothrottle FMA window displays left or right preceding the mode. For example, left speed indicates only the left autothrottle is engaged in the speed mode. The autothrottle system moves either or both thrust levers to provide speed or thrust control depending on arm switch selection and the mode engaged. The thrust levers can be manually positioned without disengaging the autothrottle. After manual positioning, in all modes except hold, the autothrottle system repositions the thrust levers to comply with the engaged mode. If armed, the autothrottle system automatically engages if the autopilot is disengaged and both flight directors are turned off. The autothrottle system will also automatically engage if either the autopilot or flight director is engaged in a VNAV mode, flight path angle or vertical speed, altitude or glide slope, and the speed is less than an FMC calculated value for 1 second, or thrust is below the reference thrust. The autothrottle will not automatically engage when the pitch mode is flight level change or toga. They will also not automatically engage below 400 feet on takeoff or 100 feet on approach. In support of stall protection, when armed, the autothrottles automatically engage if speed decreases to near stick shaker activation. The thrust is increased to maintain the greater of minimum maneuvering speed, top of the amber band, or the speed set in the MCP speed window. The autothrottle can be disconnected by pushing either thrust lever autothrottle disconnect switch. Note that the MCP autothrottle arm switches normally remain armed when the autothrottle is disconnected. Autothrottles can be re-engaged by pushing the autothrottle switch, selecting flight level change or VNAV, or pushing a toga switch. The autothrottle system can also be disconnected manually by positioning both the MCP autothrottle arm switches to off. The left or right autothrottle can be disconnected individually by positioning the respective autothrottle arm switch to off. Autothrottle disconnect occurs automatically when either thrust reverse lever is raised to reverse idle, if the thrust levers are overridden during a manual landing, after the autothrottle has begun to retard the thrust levers to idle, if a fault in the engaged autothrottle mode is detected, when both engines are shut down. We'll now introduce the autothrottle modes as they occur in a normal flight sequence. Thrust reference. Thrust is set to the selected thrust limit displayed on ICAS. Now this mode is the only autothrottle RPM command and is normally seen during takeoff and climbs in VNAV. It's also the autothrottle mode engaged with the second push of a toga switch during go-around. Thrust. The autothrottle applies thrust to maintain the vertical speed required by the pitch mode. This mode operates primarily with flight level change. It's also the initial autothrottle mode engaged during a go-around. Speed. The autothrottle applies thrust to maintain the commanded speed displayed on the PFD and HUD. Speed is set by the MCP indicated airspeed Mach selector or by the FMC. The autothrottle will not exceed the VMO, MMO, flap slat, or gear operating speed limits, or the thrust limits displayed on the ICAS. This is the normal autothrottle mode during level flight. Idle. This is a temporary mode, displayed while the autothrottle moves the thrust levers to idle. The idle mode is always followed by the hold mode when the thrust levers reach idle. This mode is normally used to initiate VNAV path descent. Hold. The thrust lever autothrottle servos are inhibited. The pilot has manual control of the thrust levers. This mode always follows the idle mode. It's also used during VNAV early descents once the autothrottles have established the initial rate of descent. The MCP provides mode and speed selection. With VNAV not engaged, the selected speed is always displayed in the indicated airspeed Mach window. With VNAV engaged, the indicated airspeed Mach window is normally blank, since the FMC selects the autothrottle modes and target thrust values. With the window blank, the pilot enters speed changes for VNAV directly to pages on the CDU. A speed intervention mode is available when the VNAV mode is engaged. Pressing the speed selector opens the blanked indicated airspeed Mach window and allows MCP speed selections to override the FMC speed values. Now this feature gives the pilot the ability to quickly override the FMC commanded speed while not affecting the values in the FMC calculations. Pressing the speed selector again will blank the indicated airspeed Mach window, returning speed control to the FMC. Now, as mentioned earlier, the autothrottles usually remain engaged all the way through landing, even during a manual landing. Thrust is automatically reduced to idle at 25 feet radio altitude in all pitch modes except toga and flight level change. In the event of a failure of an autothrottle servo, the ICAS advisory message, "Autothrottle left or right," is displayed when the respective servo fails. Recall that advisory messages only appear on ICAS and don't have an associated oral alert. The autothrottle can be operated without using the flight director or the autopilot. In this condition, the autothrottle operates in all modes except thrust. You'll rarely operate in this condition. In this module, we're going to describe the operation of the Boeing 787 AFDS pitch modes. Just like the roll modes, the pitch modes require either a flight director on or the autopilot to be engaged. When only the flight director is on, the AFDS provides guidance only. If the autopilot is engaged, the AFDS will fly the aircraft according to the engaged mode. The first mode is the takeoff go-around mode, or TOGA. This mode provides pitch and roll guidance for the takeoff and go-around phase of flight. It's engaged differently depending on whether the aircraft is on the ground or in flight. On the ground, TOGA is a flight director only mode. TOGA is engaged on the ground when either flight director switch is selected on during pre-flight, and TOGA is displayed in both the roll and pitch windows on the FMA. On the ground, the flight director PFD pitch bar indicates an initial pitch of 8 degrees nose up, which is not considered takeoff guidance, but is a normal indication. Other than the FMA indications, there are no pitch indications on the HUD during pre-flight. If the flight director switches were missed during pre-flight, the TOGA mode may be engaged on takeoff by pressing either TOGA switch with airspeed greater than 80 knots. Note, remember, below 50 knots, the only function of the TOGA switches is autothrottle engagement. They do not control TOGA functions until after 80 knots. TOGA pitch guidance is not active until liftoff. TOGA pitch guidance is indicated by the flight director pitch bar on the PFD and by both the guidance cue and the TOGA reference line on the HUD. There's no HUD TOGA takeoff mode for pitch. On a normal takeoff, the flight director guidance cue displays on the HUD at approximately 50 feet radio altitude. When a HUD TOGA takeoff is selected for roll guidance, the guidance cue displays for pitch with the flight path vector symbol during the ground-to-air transition. Other than the guidance cue appearing sooner, there's no unique pitch guidance during a HUD TOGA takeoff. The TOGA reference line displays any time the TOGA mode is engaged in flight and above 65 knots on the ground. The TOGA reference line represents flight director vertical guidance. To comply with this guidance, the flight crew should place the HUD airplane symbol on the reference line. In flight, the spacing between the TOGA reference line and the airplane symbol is the same as the spacing between the guidance cue and the flight path vector. TOGA pitch guidance varies depending on the event: takeoff, engine failure on takeoff, wind shear, or go-around. Let's take a look at the pitch guidance in each one of these situations. During a takeoff, the TOGA pitch command at liftoff is either V2 plus 15 knots or the speed at rotation, whichever is higher. Once airborne, if the current airspeed remains above this target speed for more than 5 seconds, the target speed is reset to the faster speed, up to V2 plus 25 knots. Now, if you increase the speed in the MCP airspeed window to greater than the current target airspeed, TOGA will command that speed. TOGA pitch guidance for an engine failure depends on whether the failure occurs before or after liftoff. Before liftoff, the engine failure pitch guidance is the greater of V2 or airspeed at rotation. For an engine failure after liftoff, the TOGA pitch command is based on your airspeed. If you're slower than V2, TOGA commands V2. If you're faster than V2, TOGA commands current airspeed up to V2 plus 15 knots. If wind shear is encountered, the TOGA pitch command is 15 degrees pitch up or just below the pitch limit indicator, whichever is the lower attitude. As the rate of climb increases, TOGA transitions from a pitch command to an airspeed command. The target airspeed during wind shear is either the speed in the MCP airspeed window or current speed, whichever was the greater speed when TOGA was activated. If the current airspeed remains above the selected speed for more than 5 seconds, the selected speed is reset to the current speed up to the window speed plus 25 knots. Now before we leave wind shear, we need to mention what TOGA switches can do for you. On the ground above 80 knots, the TOGA switches do more for you than just engage the TOGA mode if you forgot to arm the flight directors during pre-flight. They clear off LNAV and VNAV. The last thing you want if you encounter wind shear on takeoff is for LNAV to engage at 50 feet and VNAV to engage at 400 feet. Selecting the TOGA switches after liftoff not only clears off LNAV and VNAV, it also puts the autothrottle in the thrust reference mode and deletes any thrust or climb derates. In flight, for a go-around, TOGA is armed when the leading edge slats are extended or at glide slope capture, whichever comes first. While there's no FMA indication when TOGA arms in flight, there is an indication. Go-around displays as the thrust limit on the ICAS display. TOGA pitch guidance during a go-around is selected by one of 2 pushes of a TOGA switch. The first push replaces your guidance for roll and pitch with TOGA and puts the autothrottles in the thrust mode. You recall, I'm sure, that in the thrust mode, the autothrottles apply enough thrust to maintain the climb or descent rate required by the pitch mode. Well, the climb rate required by the TOGA pitch mode is 2,000 feet per minute. When a go-around is initiated, the AFDS increases pitch to maintain the selected airspeed as thrust increases. If the current airspeed remains above the target speed for more than 5 seconds, the target speed is reset to the current speed up to the MCP airspeed window selection plus 25 knots. Now a second push of a TOGA switch does 2 things for you. It changes the autothrottle mode from thrust to thrust reference, and the thrust reference displayed on ICAS is full go-around power, and it removes LNAV if it's armed for the TOGA to LNAV function. TOGA level off. At the MCP selected altitude, the AFDS pitch mode changes to altitude hold. When the altitude is captured, or if vertical speed or flight path angle is engaged, MCP speed is automatically set to the flap placard speed minus 5 knots, or 250 knots if flaps are up, or a speed value entered in the indicated airspeed Mach window after TOGA was pushed. Note, the pitch mode cannot be changed until above 400 feet radio altitude. The VNAV mode is used to couple FMS vertical guidance for the active route to the AFDS. VNAV provides both thrust and pitch control through the AFDS. When VNAV initially engages, the MCP airspeed window blanks. The target speed values are provided by the FMS and displayed on the PFD and HUD. The VNAV target speed is also displayed on the appropriate FMC page. With VNAV speed engaged, the pitch mode maintains the speed displayed on the PFD and HUD. If the MCP speed window is blank, the source of the speed command is from the appropriate FMC page. If the speed window is open, that is, speed intervention, the MCP selected speed is the source of the speed command. With VNAV path engaged, the pitch mode maintains the FMC-defined altitude or descent path. VNAV altitude is a temporary altitude hold mode. When the MCP altitude is more restrictive than the FMC-defined VNAV profile, the airplane levels at the MCP altitude, and the pitch mode enunciation changes to VNAV alt. Now, in the example shown here, the MCP altitude is more restrictive, so the VNAV alt mode is engaged upon level off. To continue the descent, change the MCP altitude and push the altitude selector. The VNAV path or VNAV speed mode can then re-engage. The same situation can occur during a climb. If the MCP altitude is more restrictive than the FMS, the AFDS provides guidance to level off at the MCP altitude and the VNAV alt mode engages. To continue the climb, change the MCP altitude and push the altitude selector, and the VNAV speed mode re-engages. The MCP altitude selector is also used to delete altitude restrictions and to reset cruise altitude. During climb or descent, with altitude restrictions in the FMC, each push of the altitude selector deletes an FMC altitude restriction between the airplane and the altitude set in the MCP altitude window. During climb with no altitude restrictions and the MCP altitude window set above the FMC cruise altitude, pushing the altitude select switch resets the FMC cruise altitude to the altitude in the MCP altitude window. During cruise, setting the MCP altitude window above or below the cruise altitude and pushing the altitude select switch initiates a climb or descent to the selected altitude. The FMC cruise altitude is automatically reset to the altitude in the MCP altitude window. Note, if within 50 miles of top of descent, a descent is initiated, but the FMC cruise altitude is not changed. The Boeing 787 AFDS has the ability to climb or descend at a selected vertical speed or flight path angle. The same control wheel is used for both vertical speed and flight path angle modes. The vertical speed flight path angle push button above the readout is used to select the desired mode. Depending on which mode is in use, the display is referred to either as the vertical speed window or the flight path angle window. With vertical speed in the display, pushing the vertical speed flight path angle switch opens the vertical speed window to display the current vertical speed. Roll the pitch command wheel towards up to climb or towards down to descend. Within the performance limits of the aircraft, the resulting pitch commands will maintain the rate of climb or descent selected in the vertical speed window. With flight path angle in the display, pushing the vertical speed flight path angle switch opens the flight path angle window to display the current flight path angle. Roll the pitch command wheel towards up or down to select the appropriate flight path angle. Within the performance limits of the aircraft, the resulting pitch commands will maintain the flight path angle selected in the flight path angle window. The flight level change mode is used to climb or descend directly to the altitude selected in the MCP altitude window. Flight level change speed is indicated in the FMA pitch window, and the airplane climbs or descends at the speed selected in the MCP airspeed window. The autothrottle engages in the thrust mode and adjusts thrust to maintain a 2-minute climb or descent if possible. The altitude hold mode is engaged by pressing the MCP altitude hold switch or capturing the selected altitude from a vertical speed, flight path angle, or flight level change, climb or descent. When the hold switch is pressed, the AFDS captures the present altitude and, if climbing or descending, will return to the captured altitude. The glide slope mode is armed by selection of the approach switch on the MCP. The glide slope mode engages when the capture criterion are met. With the glide slope mode engaged, the pitch follows the ILS glide slope. The glide path mode is also armed by selection of the approach switch on the MCP. The glide path mode engages when the capture criteria are met. With the glide path mode engaged, the pitch follows the FMC glide path. The flare mode is available for a Land 3 or Land 2 approach and is automatically armed. The flare mode brings the airplane to a smooth, automatic landing touchdown. During an auto land, flare is automatically armed and displayed below 1,500 feet radio altitude. The flare mode engages at approximately 50 feet radio altitude and replaces the glide slope enunciation in the FMA pitch window. During the flare maneuver, the autothrottles begin retarding the thrust levers to idle at 25 feet radio altitude, and the autothrottle enunciation changes from speed to idle. At touchdown, the nose is lowered to the runway, and the flare enunciation is no longer displayed in the FMA pitch window. There are 3 forms of flight envelope protection in the autopilot: stall protection, overspeed protection, and bank angle protection. The ICAS caution message Autopilot, along with roll and pitch mode failures indicated on the FMA, alert the crew that the autopilot has begun flight envelope protection. The autopilot prevents further envelope violations. In this module, we're going to introduce the Boeing 787 AFDS roll modes. For all AFDS roll modes, you must have either a flight director on or the autopilot engaged. When using only the flight director, the AFDS only provides guidance. If the autopilot is engaged, the AFDS will fly the aircraft according to the engaged mode. The first mode is the takeoff go-around mode, or TOGA. This mode provides pitch and roll guidance for the takeoff and go-around phase of flight. It's engaged differently depending on whether the aircraft is on the ground or in flight. On the ground, TOGA is a flight director-only mode. TOGA is engaged on the ground when either flight director switch is selected on during pre-flight. TOGA is displayed in both the roll and pitch windows on the FMA. The flight director roll bar pre-flight position on the PFD is centered for wings level. If the flight director switches were missed during pre-flight, the TOGA mode may be engaged on takeoff by pressing either TOGA switch with airspeed greater than 80 knots. Note, below 50 knots, the only function of the TOGA switches is autothrottle engagement. They do not control TOGA functions until after 80 knots. TOGA has 2 roll modes for takeoff, TOGA and HUD TOGA. Roll guidance for the TOGA mode becomes active at liftoff. It commands wings level until 5 feet radio altitude, then guidance is to maintain the existing ground track. The HUD TOGA mode provides lateral guidance for the takeoff roll and for a rejected takeoff using ILS or GLS signals. The HUD guidance cue appears when HUD guidance becomes active as the airplane approaches the runway centerline and the airplane heading is within 45 degrees of runway heading. Note, Though the flight director roll bar moves with HUD toga commands, only the HUD guidance cue is certified for use during HUD takeoffs. In flight for a go-around, toga is armed when the leading edge slats are extended or at glide slope capture, whichever comes first. While there's no FMA indication when toga arms in flight, there is an indication. Go-around displays as the thrust limit on the ICAS display. Toga is engaged in flight by pressing a toga switch. The AFDS maintains the ground track present at mode engagement. The LNAV mode is used to couple FMS lateral guidance for the active route to the AFDS. Selecting LNAV on the MCP arms the LNAV mode. This mode can be armed before takeoff and will automatically engage at 50 feet radio altitude. If not within LNAV capture criteria, LNAV will arm and subsequently engage when the capture parameters are met. Airplane must be above 50 feet radio altitude and in a position to turn onto the active route leg. We'll now describe the heading and track roll modes. The Boeing 787 AFDS has the ability to select and maintain either a heading or a track. The same selector and hold buttons are used for heading and track modes. The heading track reference switch is a small button located above the heading track window. It's used to select either the heading or track mode for display and engagement. The default mode at power-up is heading. The heading select mode is used to directly select a desired heading for the AFDS. This mode is often used for intercepts to capture another mode, such as the localizer mode or the LNAV mode. It's engaged by pressing the select button on the end of the heading track selector knob. Heading select requires that heading be enunciated in the heading track window of the MCP. If track is enunciated, press the heading track reference switch above the window to display heading. Except for the latter portion of a coupled approach, the heading select mode will engage when it's selected. When heading select is engaged, heading select is enunciated in the FMA roll window, and the aircraft turns to and maintains the heading selected in the MCP heading track window. The heading hold mode is used to maintain a constant heading. It's engaged by pressing the hold switch on the mode control panel, and heading hold is enunciated in the FMA roll window. If heading hold is selected while the aircraft is turning, the AFDS rolls out and holds the heading reached after rolling wings level. The track select mode is used to directly select a desired track for the AFDS. Track select requires that track be enunciated in the heading track window of the MCP. If heading is enunciated, press the heading track reference switch above the window to display track. It's engaged by pressing the select button on the end of the heading track selector knob. Except for the latter portions of a coupled approach, the track select mode will engage when it's selected. When track select is engaged, track select is enunciated in the FMA roll window, and the airplane turns to and maintains the track selected in the MCP heading track window. The track hold mode is used to maintain a constant track. It's engaged by pressing the hold switch on the mode control panel, and track hold is enunciated in the FMA roll window. If track hold is selected while the aircraft is turning, the AFDS rolls out and holds the track reached when rolling wings level. The localizer mode engages when the aircraft is in a position to capture the localizer beam. It's armed by pressing the localizer, final approach course, or approach switches on the MCP with a valid localizer frequency tuned on the nav-rad page of the FMC. When armed, localizer appears in small font in the lower portion of the FMA roll window. With localizer armed, the AFDS localizer capture point varies based on range and intercept angle. Maximum intercept angle is 120 degrees. When localizer has engaged, both the MCP heading window and the ND heading bug automatically display the localizer course. The AFDS provides guidance to fly the selected localizer course. The final approach course mode engages when the aircraft is in a position to capture the final approach course. It's armed by pressing the localizer final approach course or approach switches on the MCP with a valid non-ILS approach selected on the FMC approach page. When armed, final approach course appears in small font in the lower portion of the FMA roll window. With final approach course armed, the AFDS final approach course capture point varies based on range and intercept angle. Maximum intercept angle is 120 degrees. When final approach course has engaged, both the MCP heading window and the ND heading bug automatically display the final approach course. The AFDS provides guidance to fly the non-ILS final approach course. The backcourse mode engages when the aircraft is in a position to capture the localizer backcourse beam. It's armed by pressing the localizer final approach course or approach switches on the MCP with a valid backcourse approach selected on the FMC approach page and localizer frequency tuned on the nav-rad page. When armed, backcourse appears in small font in the lower portion of the FMA roll window. With backcourse armed, the AFDS localizer final approach backcourse capture point varies based on range and intercept angle. Maximum intercept angle is 120 degrees. When backcourse has engaged, both the MCP heading window and the ND heading bug automatically display the inbound backcourse bearing. The AFDS provides guidance to fly the selected localizer final approach course along the inbound backcourse bearing. The rollout mode automatically arms on approach and engages at touchdown. Specifically, the rollout mode arms when Land 3 or Land 2 is enunciated on the ASA below 1,500 feet radio altitude. When armed, rollout appears in small font below localizer in the FMA roll window. Rollout engages at touchdown with weight on wheels. Upon engagement, rollout replaces the localizer mode FMA roll enunciation. The autopilot controls the rudder and nose wheel steering to keep the airplane on the localizer centerline. During rollout, the autothrottle idle mode remains engaged until the autothrottle is disengaged. The autothrottle will automatically disengage when reverse thrust is selected. Rollout guidance continues until the autopilots are disengaged.